Hello everyone, welcome to the Brain of Science Academy. In this video, I will be explaining about the important topics and important points regarding for your Kcet examination from the P block chapter. So let us look into the first group 15. They are also called as a nitrogen family. The members belong to the nitrogen family or as nitrogen, phosphorus, arsenic, bismuth. So general electronic configuration is NH2 NP3 and these group members are also known as nicogens, meaning suffocations. So when come to the physical properties of this group, the ionization enthalpy of these group members are high due to off-filled valence shell, and as well as ionization enthalpy decreases down the group due to the increase in their size. So next, another important point will be the electronegativity decreases down the group. So the electronegativity decreases down the group. So which means nitrogen will be having the greater electronegativity than the bismuth. So next, catenation will also decreases as we go down the group. So next, coming to the halotropy forms, except bismuth in this group, all other elements shows the halotropy form. Like nitrogen will be forming as a alpha and beta nitrogen, phosphorus will be having white or yellow, red and black phosphorus, arsenic will be grey, yellow and black, where Sb will be having the metallic and yellow antimony. And another important point in the physical properties will be nitrogen show greater tendency to form pi-pi multiple bond with itself as well as with the carbon and the oxygen atom. So he point ಸ್ವಲ್ಪ ನೆನ್ಪಿಟ್ಕೊಂಡಿರಿ, only the nitrogen atom have the greater tendency to form the pi-pi multiple bond. So next, another important point is phosphorus, arsenic and Sb exist in form of P4, As4 and Sb4 due to the formation of 3 sigma bonds. Due to the formation of 3 sigma bonds, phosphorus exists as a P4, arsenic exists as a As4. So next we shall look into the chemical properties. In that, first about oxidation state. So the oxidation state ranging between -3 to +5. So -3 to +5 will be the oxidation state for group 15 elements, whereas negative oxidation state will be exhibited when they combine with less electronegative element, and positive oxidation state will be excited with more electronegative element. So e point ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ about an oxidation state. Negative oxidation state will be exhibited when they combine with the less electronegative elements, and positive oxidation state will be exhibited with more electronegative element. And due to inert pair effect, the stability of +5 oxidation state will get decreases. So whichever the element will be having a +5 oxidation state, it gets decreases. Okay, now due to inert pair effect, the stability of +5 oxidation state will get decreases. Next we shall look into the hydrates. So the bond angle decreases due to the decreased bond pair repulsion. So I have given even the bond length of each hydrates of group 15 element. I have mentioned the values also. Please look into it. So you should know about the bond angles of the hydrates. So next, the bond character decreases due to the availability of lone pair. Boiling point will be more in the phosphorus trihydride when it's compared with an bismuth hydride. So again here the NH3 molecule will have the higher boiling point. It shows the high boiling point due to the intermolecular hydrogen bonding. So due to intermolecular hydrogen bonding in nitrogen, it shows the higher boiling point. So next, the reducing character increases down the group at strength of metal hydrogen bond decreases. So the reducing characters will be as follows. NH3 will be lesser than the PH3, lesser than the ASH3, lesser than the SBH3, and lesser than the bismuth trihydrate. So in hydrates, these are all very important points should be remembered. So next, coming to the halides. So all the group members forms a trihalides and pentahalides. The ionic character of the trihalides increases as we move down the group. Okay, now as we move down the group, the ionic character of trihalides will get increases, except NCl3. ಇದೊಂದು ಪಾಯಿಂಟ್ ತುಂಬ ಇಂಪಾರ್ಟೆಂಟು. Except NCl3, all trihalides are hydrolyzed by water due to the absence of d orbitals in the nitrogen. Okay, na? So except NCl3, all trihalides are hydrolyzed by H2O. And nitrogen cannot form nitrogen pentahalide due to non-availability of d orbitals. Due to non-availability of d orbitals, nitrogen cannot form as a nitrogen pentahalide. Bismuth also cannot form as BiX5 due to the reluctance of 6s electron in the bismuth. So next, coming to the trihalides. So the trihalide having the sp3 hybridization, shape will be the pyramidal. So MX3 element compounds will be having the sp3 hybridization and the shape will be the pyramidal. Same as for pentahalides, the hybridization will be the sp3d and the shape form will be the trigonal bipyramidal. So these important points, go through it. So next, look into the oxides. So the basic nature of the oxides increases with increase in the atomic number of the element. So as the atomic number of element increases, the basic nature of the oxides will also get increases. So nitrogen forms a number of oxides, whereas rest of the members of the group form two types of oxides. Which are two types of oxides? One is E2O3 and another will be E2O5. So except nitrogen, all the remaining members of group 15, they form as E2O3 and E2O5 oxides. Next, we shall look into the oxides of nitrogen. So oxides of nitrogen are N2O, NO, NO2, N2O3, N2O5. So N2O will be having the +1 oxidation state. It is a neutral compound. It means it is neutral in the nature, and it will be having a diamagnetic, and it is used as a anesthetic. And N2O is also called as a laughing gas. N2O is also known as laughing gas. So next, NO. NO will be having the +2 oxidation state, and it is also a neutral in nature, and it is a paramagnetic, and it is a dimer in diamagnetic. It is a dimer is diamagnetic. So NO will be the paramagnetic, the dimer form of NO will be the diamagnetic. So next, NO2. NO2 will be having the +3 oxidation state. It is acidic in nature. It is a paramagnetic. And knowing about the properties, NO2 is a pungent smelling gas and it forms as a brown fumes. So next, N2O3 will be having the +4 oxidation state. It is acidic in nature. It is an anhydride of HNO2. It is an anhydride form of an HNO2, and it will be it's one of the property will be it's a pale blue solid. So next oxide will be the N2O5, which will be having the +5 oxidation state, acidic in nature, and it is also an anhydride form of an HNO3. So next, we shall look into the phosphorus. The ores of phosphorus will be phosphorite and chlorapatite. So I have written the molecular formula of both phosphorite and as well as for the chlorapatite. Please look into it. So next, coming to the allotropes of phosphorus will be white, red and black phosphorus. White phosphorus, we can call it as white or as a yellow phosphorus. So let us look into the properties of white phosphorus. They are poisonous, they are soluble in carbon tetrachloride and carbon disulfide. So this point is important, please look into it. So white phosphorus will be soluble in CCl4 and CS2. They are less stable and they are very reactive, and the structure of white phosphorus will be P4 unit structure. So the structure of white phosphorus will be P4 unit structure. So next we shall look into the red phosphorus. They are non-poisonous. They are insoluble in CCl4 and CS2. So red phosphorus are insoluble in CCl4 and CS2. They are odorless. They are the most stable. They are less reactive. So these are the important points. Go through it. So they are odorless. They are most stable. Red phosphorus are most stable when compared to an white phosphorus. They are less reactive and they form polymeric structure. So next, black phosphorus. They are non-poisonous, colorless, most stable, less reactive. Almost the black phosphorus and the red phosphorus properties are same. They both are similar, but the structure will be double layered structure for the black phosphorus. Black phosphorus will be having the double layered structures. So next we shall look into the oxoacids of phosphorus. Oxoacids of phosphorus will be H3PO2, which will be known as an hypophosphorus acid. Next one will be the H3PO3, phosphorus acid. H3PO4, orthophosphoric acid. H3PO5, peroxo, clean up ಕೇಳಿಸ್ಕೊಳ್ಳಿ. Fourth one, H3PO5 is called as an peroxo monophosphoric acid. So next, HPO3, it's a phosphoric acid. H4P2O7, it's an pyrophosphoric acid. Next, H4P2O6, hypophosphoric acid. H4P2O5, pyrophosphorus acid. So don't get confused of between a sixth one and the eighth one. H4P2O7 is called as an pyrophosphoric acid, whereas H4P2O5 it is called as pyrophosphorus acid. And each phosphorus atom in the oxoacids of phosphorus will be having sp3 hybridization. So the phosphorus will be having sp3 hybridization. Next we shall look into the group 16. It's also called as an oxygen family. The members of group 16 are oxygen, sulfur, selenium, tellurium and polonium. The general electronic configuration of group 16 will be NS2NP4. They are called as an chalcogens. They are called as chalcogens, means they are ore forming substance. They are ore forming substance. So next we shall look into the properties. Ionization potential is lower than the group 15, which means the ionization enthalpy is lower when it is compared with an group 15 elements. Next, electron affinity is high except for oxygen. So except for oxygen, all the elements will be having the low electron affinity only. Why oxygen atom will have higher electron affinity means because due to its small size, oxygen will have low electron affinity. So next, look into the allotropy forms. Oxygen will be having O2 and O3. Sulfur will be having a rhombic sulfur and monoclinic sulfur. Selenium will be having red and grey. Tellurium will be having non-metallic and metallic. So next, another important properties of group 16 will be like oxygen is most abundant element when compared to other member of this group. So oxygen atom will be the most abundant element. Next, electronegativity decreases down the group due to decrease in the effective nuclear charge down the group. So this point ನೆನಪಿಟ್ಕೊಳ್ಳಿ. Usually now electronegativity decreases down the group ಅಂದಾಗ because of the size ಅಂತ consider ಮಾಡ್ಕೋತೀವಿ. But this is also another point due to the effective nuclear charge. That is also an important point. So next we shall look into the chemical properties. So for group 16, only -2 oxidation will be shown by oxygen only. Other elements shows the +2, +4 and +6 oxidation state. Except oxygen molecule or oxygen element, remaining all will be having the +2, +4 and +6 oxidation state. Oxygen will be having the -2 oxidation state. Next, stability of +4 oxidation state increases down the group due to inert pair effect. So most of the properties are discussed based on the inert pair effect. So know about the inert pair effect. So stability of +4 oxidation state increases down the group. Next, oxygen is a diatomic, whereas sulfur and selenium are octaatomic. So ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, oxygen atom or oxygen element only will be having the diatomic, and remaining all the members will be having an octaatomic and with puckered ring structure. And with an puckered ring structure andre it will be like this is the structure of the puckered ring. So sulfur and selenium are octaatomic with an puckered ring structure. So due to pi-pi bond, oxygen exists as O2 molecule. So due to pi-pi bond, oxygen exists as an O2 molecule. So next we shall look into the hydrates. Hydrates or H2O will be in the liquid, and remaining all like H2S, H2TE, H2SE are gases. Only H2O will be the liquid and remaining all hydrates will be in the gas form. Next, coming to the boiling point, obviously H2O water molecule will be having the higher boiling point due to hydrogen bonding. So next, bond angles will be H2O will be the greater bond angles when it compared with an H2S, and again compared H2S is compared to an H2SE. H2S will be having the greater. So next, coming to the reducing character, H2O water molecule will be the least reducing character, and H2TE will be the greater reducing character. So next, coming to the halides. So oxygen forms an OF2, Cl2O and Br2O. So oxygen atom forms as OF2, Cl2O and Br2O. And next, compounds of O and F are called as fluorides. Compounds of O and Cl, Br or I are called as oxides. Why compounds of oxygen and fluorine are called as fluorides? Because fluorine is more electronegative than oxygen, but other halogens are less negative than the oxygen atom. So due to this reason, compounds of oxygen and fluorine are called as fluorides. So next, selenium and tellurium, they form SeF6, TeF6, and chlorides and bromides, which means like selenium and tellurium are reacted with the chlorides or bromides, they exist in a +1, +2 and +4 oxidation state. So e point nenpalirli, when an selenium reacts with an chloride or bromide, they exist in a +1, +2 and +4 oxidation state. So all elements except oxygen for hexafluorides, they have sp3d2 hybridization and octahedral shape. All the elements except oxygen for hexafluoride andre OF6, except OF6, remaining all will have an sp3 hybridization and octahedral shape. Next point, all elements except oxygen form tetrafluorides except OF4. Remaining all have an sp3d hybridization. remaining will have an sp3 dehybridization. So next we shall look into the oxides. The elements form oxides of +2 to +6 oxidation state. The elements form an oxides of +2 and from +2 to +6 oxidation state. So the acidic character will be greater in the sulfur oxide when it's compared with an polonium oxide. SO2 will be having the greater acidic strength than the POO2. Next we shall look into the properties of oxides, where SO2 will be the gas at room temperature and it acts as both oxidizing and reducing agent. SO2 will act as both oxidizing and reducing agent. It is anhydride form of H2SO3. It is an anhydride form of an H2SO3. Next, SO3 is an acidic oxide. It is an oxidizing agent only. It does not reduces anything. So it is an oxidizing agent and it is an anhydride form of an H2SO4. It is anhydride of H2SO4. Next we shall look into this sulfur. Sulfur is used as vulcanization of rubber. Sulfur is used as vulcanization of rubber, and sulfur exists in two allotropic forms, right? One will be the rhombic sulfur, another will be the monoclinic sulfur. So now the properties of rhombic sulfur will be, the melting point of rhombic sulfur is 385.8 Kelvin. The melting point of rhombic sulfur is 385.8 Kelvin. It is insoluble in water, but it is soluble in alcohol, ether and carbon disulfide. Even it shows solubility in benzene also. Even it shows solubility in benzene. So next we shall look into the monoclinic sulfur. The melting point of monoclinic sulfur will be 393 Kelvin. It is soluble in CS2, carbon disulfide. It shows solubility in carbon disulfide, not with the other organic solvent. It is stable only at above 369 Kelvin. It shows, or it gets stabilized only above the 369 Kelvin. So these are the important points on topics of groups 15 and group 16 for your Kcet. Along with this you will be having some preparations. So usually for the Kcet they won't ask more from the preparations, especially from this P block. They ask more about the properties only. So go through it, and whichever the important points I have said, again revise those important points. And in the next video I will be discussing about the group 17 and group 18. Even if you want to look into the preparations, especially the nitrogen, so in that the preparation of from the lab method is another important reaction. So in lab method what we happens in there, you take an NH4Cl plus NaNO2. So from using an NH4Cl and NaNO2 we get an nitrogen will be produced along with the water molecule. So this will be the one of the important reactions in the preparation of nitrogen. And another will be the Haber process. You already know from your board preparations only will be known. So next coming to the preparations part, they might ask you about the Nestle's reagent. They might ask you about the Nestle's reagent, where the Nestle's reagent molecular formula will be K2HgI4. This will be the Nestle's reagent. It is used to detect the presence of an ammonia, and the observation will be the reddish brown precipitate. Or even they might ask you the reaction. So the reaction for Nestle's reagent will be K2HgI4 when it is reacted with an ammonia in the presence of an water molecule. You will get an H2Hg OHGI. This is also called as a Millen's base. It is also called as a Millen's base. So the reddish brown precipitate will be formed, right? That one will be known as the Millen's base. So apart from that, anomalous behavior of the all the group of all the elements, you should be known. You will be already prepared for your board examinations. So next will be the Oswald process, contact process. So all the four manufacture process which were there, you have to prepare those process or manufacturing process also. So apart from this, very important are will be physical and chemical properties only will be more from this P block chapter only. Just go look into it. That's enough. Next, the remaining group 17 and group 18 I will be discussed in the next upcoming video. Thank you all.